Hi, my name is Darshan and I'm an online tutor of math and physics. This is FRQ number 6 AP Calculus BC 2023 exam based on oops, this is the mic. Based on Taylor polynomial and the Lagrange multipliers. So over here, let's read this question out. Remember, this is important. They always ask one of the FRQ based on this question. This topic, I mean. Find f. Okay, the function f has derivatives of all orders for all real numbers. Let us define. It is known that f0 is 2, f prime 0 is 3, f double prime x is, oh my goodness, negative f of x squared, f triple prime x is negative 2x, f prime x squared, Jesus. Find f raised to 4x, and let us find the fourth derivative of the function with respect to x, and write the fourth degree Taylor polynomial for f about x. Okay, x equal to 0, that's a relief. Show the work that leads to your answer. Okay, let's work on f fourth x, the fourth derivative of x. Obviously, I'm going to start my journey with the third derivative, which is already given in the question as negative 2x f prime of x square. And I'm going to take the derivative on both the sides, and 1, 2, 3, 4. Or you can write 4 as a number. Of course, negative 2 comes out because that's a constant. I'm going to write d over dx of x times f prime x square. Why I'm writing like this? Because you have to use the product rule. So the product rule says that first term as it is, you find the derivative of the second term, plus the second term is as it is, you find the derivative of x. And what is the derivative of x with respect to x? That's 1, you're right. This is going to look like negative 2 times x of, what is the derivative of f prime x square? A little bit of chain rule is helpful over here. The derivative of f prime is just f double prime, and x square remains as it is. However, you need to go inside and you have to find the derivative of this x square as well, which is 2x. Plus f prime x square remains as it is. Let's open everything up and write in a single expression without the parentheses, which is negative 2x, not negative 2x, right? Okay, I'm gonna write one more step as in negative 2 and 2x times x is just 2x square f double prime x square plus f prime x square. And let me separate my work. Okay, and now I'm gonna ram this negative 2 inside, so that's gonna look like negative 4x square f double prime x square minus 2 f prime x square. That is the value of the, that is the expression rather for the fourth derivative of the function. I'm gonna keep this with me because I will be using this. As we are not done yet, we need to find a fourth degree Taylor polynomial as well about x equal to 0. So obviously I need f0, f prime 0, f double prime 0, f0, f prime 0, double prime 0, triple prime 0, and 4 prime 0, all the primes at 0. So let's find that first and then we'll write. It will be easy to keep a track, you know. Yeah. What is f of 0? Well, it's already given in the question. Very good. That's 2. What is f prime 0? That's also given in the question. Excellent. Why don't they give everything in the question? F double prime 0. What is f double prime 0? We gotta use this one. So f double prime 0 will be minus of f of 0 square, and 0 square is, oh my goodness, that's 0. So this is negative f of 0, and what is f of 0? That's 2. So minus of f of 0 will be minus 2. F triple prime 0 is going to be, I'm going to put 0. I'm not going to calculate this because that's just 0 multiplied with f prime 0. I don't really care what f prime 0 is because 0 times that is just 0. And the fourth derivative, 1, 2, 3, 4, 0 is going to be, this is 0. Okay, I like this. Why? Because x is 0, so 0 times the same story, 0. And this will become just negative 2f prime 0 or 0 square, if you mind if I write 0. 0 square is 0, and yeah, It's negative 2 f prime 0, just getting a little lost for a moment, but yeah, f prime 0 is 3 and negative 2 times 3 is negative 6. Whew. So we have all the zeros written over here for the fourth degree. Of course, you know what I'm going to do. I'm going to erase everything because I need more space. And now we are all set. So the function f is approximately given by f of 0 plus f prime 0 over factorial 1 times x. Why x? Because I'm finding about 0, so I don't really care about x minus 0 or whatever, it's just x. Plus f double prime 0 over factorial 2x square plus f triple prime 0 over factorial 3x cube. I'm going to write on the next line f fourth derivative of 0 over 4 factorial x raised to 4. This is where we need to stop because they are asking for fourth degree. Fortunately, we have the values of everything written over on the right blue. So this is 2, this is 3, 1 factorial is just 1, so that's just 3x. F double prime 0 is negative 2, 2 factorial is just 2. F triple prime 0 is 0, excellent, so I'm not bothered about these terms, it's just 0 times everything is 0, 0 thing. And this is negative 6 and 4 factorial is 4 times 3, 3 times 2, 4 times 3 is 12, 12 times 2 is 24, 24 x raised to 4. Finally, its value comes out as 2 plus 3x. Negative 2 over 2 is just negative 1, so that's negative x square. And 6 times 4 is 24, so that's negative 1/4 of x raised to 4. I hope this is the correct answer. Let me know what you think about this in the comment section. So this is the approximate function f using the Taylor polynomial. Okay. Next question is Lagrange error, very popular. Okay, the fourth degree polynomial f about x equal to 0 is used to approximate f of 0.1. It is given that its fifth derivative is always less than or equal to 15 for x bounded between 0 to 0.5. We need to use the Lagrange error bound to show that this approximation is within the 10 raised to 5 of the exact value of f of 0.1. Right, so we know that the Lagrange bound, first of all, what is the Lagrange bound? The value at f of some value at a is always less than equal to, as per the Lagrange bound, m times absolute value of x minus a raised to n plus 1. Rather than writing this as f of a, I'm going to write that it's error for the, in fact, the absolute value of, it's okay, yeah, it's absolute value, error at the fifth derivative. So error at the, yeah, it's absolute, the fourth degree polynomial. So error for the fourth degree polynomial, so I'm going to write this as error for the fourth degree polynomial, is less than or equal to m times absolute value of x minus a raised to n plus 1 over n plus 1 factorial. The most difficult part is to find the value of m, because m is the largest value of the fifth derivative, fifth as in just immediate next of what we are finding. So this is, we are finding 4, so that is fifth. Fifth derivative's maximum value. Fortunately, it's already given to us that the fifth derivative's maximum value is 15, so the value of m is 15. So I'm going to replace m with 15, and x is 0, and the value of a at which we need to find is 0.1, because that's where we need to get the approximate value. N plus 1 will be 5 over 5 factorial. My goodness, that's too much. Calculator is not allowed. So 15 remains as it is. This just becomes 0.1 raised to 5. What is 5 factorial? It's 120, but if you don't remember these factorials till maybe 5 I remember till 5 factorial, but anyway, if you don't remember, we can always write it as 5 times 4 times 3 times 2, 2 times 1. 5 times 3 is 15, and 15 is gone. If you don't understand like this, 5 times 3 is 15, and 3 is gone. So I'm left with 4 times 3 is 12, correct? I'm left with 4 times 3 as 12. Oh, sorry, it's not 4 times 3, it's 4 times 2, right? 4 times 2 is 8. So we know that the error should be less than equal to 1 over 8 times 0.1 raised to 5. What is 0.1? 0.1 is nothing but 1/10. So 1/10 raised to 5. So this should be less than equal to 1/8 of 1/10 raised to 5. And 1/8 is a number which is less than 1. So if it is less than a number which is less than 10, 1 over 10 raised to 5, obviously it must be less than the other guy, as in 10 raised to 5 as well. That's what we need to prove, right? It's like saying if a number n is less than equal to 2, so obviously the number must be less than 3 on that page. So we are writing 10 raised to 5 because that's what they intend to, that's what they want us to prove, that it is within 1 over 10 raised to 5 of the exact value. So we know that the error is of course less than, in fact we are going to say it's less than 10 raised to 5, and in this way we actually have proved that the error is less than 1 over 10 raised to 5. So the Lagrange error is important. This is how we prove it. Hope this makes sense. And the last part on this is this. This is relatively easy. We are given the value of we are given a function g prime for color g prime, and we need to find a second degree Taylor polynomial for g about x equal to 0. So second degree means definitely that we need to go till g double prime, right? G double prime. So g0 is already given to us as 4. G prime 0 will just be this, which is e raised to 0 times f of 0. E raised to 0 is 1 and f of 0 is already given here as 2. So that's 1 times 2, which is obviously 2. And to find g double prime, we are going to just take the derivative once again of e raised to x fx. So g double prime is going to look like, that's going to be product rule, right? So e raised to x as it is, find the derivative of x, which is f prime, and then f as it is, and we find the derivative of e raised to x, which is e raised to x. So g double prime 0 is going to look like e raised to 0 times f prime of 0 plus f of 0 times e raised to 0. Let me separate my work over here, and this is going to look like e raised to 0 is 1, f prime 0 is, fortunately it's given as 3, plus f0 is 2 right here, and e raised to 0 is just 1. So 3 plus 2 is 5. We got the value of g double prime 0 as well. Let me actually box these up, otherwise it will be difficult to keep track of these. So the Taylor of g is approximately g0 plus g prime 0 over 1 factorial x. Why x? Because again it's about x equal to 0, plus g double prime 0 over 2 factorial x square. g0 is 4, we have boxed everything. G prime 0 is 2, 1 factorial is 1, so it's 4 plus it's 4 plus 2x, and then the value of g double prime 0 is 5, and 2 factorial is just 2, so it's 5 over 2 x squared. This is the approximate function g, the approximate Taylor function g of second degree. So this is our final answer. Of course we can write in the standard form, writing x squared first and then 2x and then 4, but yeah, that's fine. So this is the last part of the last question of this exam. I hope this makes sense. Any questions, feel free to ask in the comment section, and if you like this video, please subscribe to my channel. Bye bye.